Okay, so now we're going to talk about these things called definite integrals, and they are different to indefinite integrals, and you will see why. It's because of this reason. So here, I've taken the scenario of a car driving along, its speed's increasing, and what if I don't care about the whole journey? What if I only care how far it's travelled in a certain time, okay? If I only want to know how far it's travelled between 2 seconds and 8 seconds, how would I work that out? Because at the moment, all I have is the tools to figure something out at an exact moment. So I could say how far it's travelled at 8 seconds, and I could say how far it's travelled at 2 seconds. But how do I figure out how far it's travelled between 2 and 8 seconds? Well, it kind of makes sense. What you'd have to do is you'd have to take the greater one, the greater distance, and take away the smaller distance, which makes sense, really. You know, if I want to know how far I've travelled between 2 and 8 seconds, what I do is figure out how long I travelled in 8 seconds, then take away how long I travelled in the first 2 seconds, and that leaves you with the remaining distance. So yeah, like I've said here, your area between 2 and 8, just call this area or distance or whatever, but your area between 2 and 8 will be equal to your area between 0 and 8 minus your area between 0 and 2. And when we're writing this out in integration notation, you'd write it like this. You'd say a is equal to the integral between 2 and 8 for f of x with respect to x. And you always put the larger number on top, and it's always the bigger number minus the small number. So this really would look like this. So it would be equal to the integral of f8 minus the integral of f of 2 dx. Just put those in brackets. Okay, so on to like the formal notation. So what this means is saying the area of a graph y equals f of x, so this flat line here, and the x-axis, so the area between the graph and the x-axis from points where x is equal to a here and x is equal to b can be described by this formula here. So the integral between a and b of f of x dx is equal to this, okay? Should really be in brackets, but it's okay. So this is called the definite integral. And if you think about it makes definite, it makes sense, okay? Because the other one was indefinite. So we didn't know where it was going to start. We didn't know how far it was going to go. We didn't know if it was going to shift up and down. And because of this definite, we definitely know where we're going from A to B. We don't need to worry about this constant of integration, okay? Because this is like a specialized case where we know exactly what we're looking for. Whereas when you had an indefinite one, we didn't really know. We had to make it sure it was going to be right for all situations. So that's why you need to have that plus c in there. But for this one, you won't need the plus c. It's just, again, a bit more notation, where a is called the lower limit of integration and b is called the upper limit of integration. So it's always the top minus the bottom. Okay, I'm going to do some examples now.